Alright, it should be live. I'm gonna give the stream a little bit to warm up. Get my chat open. Play a little bit of music for myself. Cool. All right. Well, welcome to anybody who might be tuning in. Yeah, so this is the 7th stream in this series. And I'll just pick up from where I left off last time. Right. So I was looking at the station data, right? The specific station, this Grigg Street station. And I was doing a little bit of really simple analysis. The Stealth Pawn, what's up? What's up? Welcome to the stream. Glad you could join. Feel free to interact as you wish. Ask questions, provide feedback. I'm very, very excited to have you in the audience. All right. Let me also, I'm going to set a timer for 30 minutes so I don't spend too much time on this. But yeah, so I'll just kick off with where I left off last time with the script. So I'm just going to run this script and we'll see what it does. There we go. All right, so we had taken all of the capacity data for the station over time, and on the left we plotted the histogram of basically the number of times the station existed within all of these different capacity percentiles, right? Where capacity is defined as the number of bikes available at that station to the total number of bikes that station could hold, right? So 0% is totally empty, 1 is totally full. And then we saw, right, that the station is very, it's very underserviced, right? Because you see the histogram shows that the most probable state for the system, for the station, is at 0% capacity. So that's a problem. Hello, Intrepid Voices. Welcome. Is there going to be a recap? So, first, thank you for the question, and thank you for attending the stream. Parts 1 to 6 should be on my YouTube channel. They are all recorded. You can watch the playbacks. Part 1 is kind of a quick and dirty summary of the project. I haven't done an actual, like, sort of, dedicated kind of like project overview video. But I think if you go to Part 1, you'll get a good introduction into this project. Yeah, sorry, I'm not gonna do too much of a recap in this video. This is not an IDE. I don't run things. Well, I will eventually when stuff gets more involved and I have a lot more code and I need to look at a lot more data. I'm going to be switching over to an actual IDE. Hopefully, I'm going to check out something called Spider, which is, I think, Python's version of like a MATLAB-like IDE GUI interface. So that would be really nice. But for now, yeah, I'm just doing sort of a quick solution, which is just running code on the command line, writing code in Sublime. Cool. So, right. So with the last stream, I made this plot over here on the right, which is I took each of these buckets, or I took a sample of 3 of these buckets, right? I wanted to look at all the data when this station was at 0% capacity, for example, and I wanted to see a histogram of all of those entries versus hour of the day, right? So that's what this plot here is showing, right? And then basically what I concluded is that the station spends a good amount of its time, right? The probability of the station being at 0 capacity is very high between the hours of like 9 a.m. all the way till the evening, about 5 or 6 p.m. And that's not good, right? That's not what you want to see for a healthy station. A healthy station should be at about 50% capacity throughout the day, right? But that's not the case that we see here. And then we also see this station is rarely ever at nearly full capacity. Spider's all right. I like PyCharm more. Yeah, okay. So you've tried both then. I've definitely used PyCharm a good amount. But the reason I wanted to use Spider is because this is very much a data science project, and I believe Spider is better at visualizing variables in large data sets. But correct me if I'm wrong, because I've used PyCharm before, and I haven't really found a sort of like MATLAB-like interface in PyCharm that lets me look at all the variables in sort of a table format. VS Code all the way. I'm gonna guess that is Visual Studio. What is VS Code? I've never heard of that. Is that for Python? So okay, yeah. So back to this. So what I wanted to do today, right, was actually to capture these histograms, but for different ranges of capacity, right? So I want to know what is the probability distribution that the station will be between 0% capacity and 33% capacity, for 1/3. And then what is the probability, right, versus time of day between 1/3 full and 2/3 full. And then from 2/3 full to max. Yes, Jupyter Notebook. I have used Jupyter, and I like Jupyter as well. Jupyter is pretty nice. It's a little bit slow on my machine because I don't know, it's running through the web browser, and my machine's not the fastest. But I do like Jupyter is also MATLAB-like in that you can script things and run things section by section, and that's also something that I might switch over to. But for now, this is doing me just fine. Alright, so all the way down to the bottom. Right, so the plan is, what do I want? I want to capture all of the occurrences when the station is, let's say, between 0 and 1/3 full. So I'm just going to write that down in pseudocode. So capture all the instances when the station is capacity is between 0 and 1/3, right? And then from those instances, what I want to do is I want to count number of instances versus hour of day. And I've already done some like iteration of this this code, so all I have to do is kind of borrow from what I already had. For example, here, this gives me this gives me all the occurrences when the station is between a certain capacity range, right? So let's make this right now for specifically from 0 to 30% or 1/3. So get instances when station is between 0 and 1/3 capacity, right? And then so what this variable is it's a Boolean vector that tells me true if the station is between 0 and 1/3 capacity, and false if it's not. And I have this vector which is capacity versus time, where I've sampled the capacity of the station in 5-minute increments, starting from like late November up to today. So all I have to do is say, well, I want the instances when this is greater than 0, greater than or equal to 0, and less than 1/3, exclusive. Cool, great. Now from that, I get to do this. So this line of code right here lets me get a vector of all the hours when this capacity versus time array was within this capacity range, right? And so that's what this Boolean vector is for indexing this vector of hours, where hour is the hour that I had sampled that data, right? And then finally, the last thing to do is just to count the number of occurrences per hour. And this code is maybe a little bit more sophisticated. I don't know if I quite remember how this worked, but I had put this together in the last stream or previous streams. But so for now, I'm just going to assume that it works, right? Now, there's not always a need to understand what previous code did. And then I just want to, from this data, plot a histogram. So let's see, count the number of occurrences per hour, and I'm gonna move this part 0 to 33%, let's say. I'm just kind of giving it a random name for now. And then eventually, or next, I'll be putting this into a for loop. And so now we will plot histogram of counts versus hour of day when station is between 0 and 1/3 full. Cool. So we do plot.figure. This is using matplotlib. And then we'll go ax1.bar, doing a bar plot, right? We'll do range 24 hours in a day, and this variable right here. I'll set the title. Actually, I don't even need this. I should be using plot. And then I will set the title as counts versus hour of day when station is between 0 and 1/3 full. All right, cool. Let's give this a shot, see if it works. And then while this is running, let me read some more chat comments. Oh no, there's a syntax error. That is unfortunate. So where is it? On line 230, hour vec in percentile range equals hour vec. Okay. Why is this telling me this is incorrect syntax? It looks fine to me. What is wrong with this? I'm indexing with square brackets. This variable exists. That variable definitely exists. How about I will give this another go. Still. That is strange. Huh. Is there no problem if I don't have this code? Huh. Ah, I see what it is. For some reason, it's actually the code, it's the line before it. That's really annoying. I was missing a parentheses. Closing bracket. Alright, there we go. There we go. Sweet. No, has no attribute, set title. How did I set titles before? Oh, it's just title. Got it. One more try. Stealth Pond. Looking into pandas and queries through that will probably help clean it up more than pure NumPy. Interesting. Okay. So you're saying that there might be functions in pandas and queries that already do what I'm trying to do? I will definitely look into that if that is the case. Yeah, because I've done a lot of sort of like NumPy indexing work to get these histogram plots. Cool. All right. So here we go. This is a histogram of showing the probability distribution, basically, of when you can expect the station to be between 0 and 1/3 full, right? And as I had suspected from before, right, the station is pretty empty in the middle of the day, right? And that's because people are checking out all the bikes in the morning to go to work, and then they're returning the bikes back home at night when they're getting off work, leaving this really massive gap of supply during the day. The Stealth Pond, yes, essentially. Okay, gotcha. Yeah, I just minimized the code on accident. There we go. Cool. All right. So let's do this for the other percentile ranges. Right, so I'm just going to wrap this code into a for loop. And I'll say, well, the ranges I want are between, right, so I'll go like this, right? This, I can kind of hard code this actually, because I know that I just want to do 3 ranges. So I'll go iRange equals, or sorry, iRange in range 3, right? And then we'll get the instances when the station is in range. In this case, range will start at iRange times the times 1/3 over 3.0, and then less than iRange plus 1 times 1/3. Get the hours for that, and then count the occurrences, and then I'll need a vector, an ND array here of size 3. I think it's just like this, right? Counts per hour, per range, let's call it that. And that'll be what I get to set. Actually, sorry, this has to be a 2-dimensional array, which, right. We'll say the number of rows is the number of hours, the number of columns is the number of percentiles. And then we will have to save in every loop the number of hours as a vector, the counts per hour, and then the range. And then I was using subplots before to plot this data, and so I'll do that again. But subplots, I want them all to share the same y-axis. And then I just need to switch out these different variables, and this will be, the titles will be 0 to, am I having performance issues? What do you mean? Could you elaborate? Is the stream lagging? Or is like the resolution dropping? This is going from 0 to 1/3 capacity, and then this one from 1/3 to 2/3, and then oh, I see. Sorry, that was in response to the right. Okay, not the actual stream itself, but the speed of this code that I'm running. Yeah. Sorry, let me read that comment. So functional programming via pandas also helps avoid loops. Things like group by and apply are faster than loops. Ah, okay, interesting. And that's because, well, you're saying, okay, also scaling to larger data sets, and makes it more cleaner looking. Right, okay, interesting. Yeah, I that's good to know. I actually haven't really looked into pandas at all. Yeah, I guess this is one of those things. I think if I was doing this in MATLAB, I would have used a lot more sort of like MATLAB functions to replace a lot of these for loops. And I'm guessing you're saying pandas kind of does the same thing there. So I'll definitely look into that. So thank you. But for now, this is working just fine. And my data set's not too large that I can't just do loops and stuff. Although I am doing some, well, I mean, I'm doing some like Boolean work, and I'm using some NumPy functions like counting the number of non-zero elements. Yeah, the less for loops I need to use, the better usually in sort of data science work. All right, cool. Let's have a look at this. Sweet, there we go. All right. So hopefully this is clear. The this plot's showing the histograms for, you know, the 3 percentile ranges of capacity that I was talking about, right? When we're at low capacity, at what I would consider healthy capacity, and then when the station is too full. And we could see, yeah, the trend's basically very obvious, right? The station spends way too much of its time being in the underserved capacity, and it peaks during the middle of the day when everyone has checked the bikes out. You know, and then that represents as a dip as well in the other percentile ranges. Rarely do you ever find this station to be totally empty, and then sometimes you find the station to be in sort of the healthy range. But ideally, it would just kind of be, this plot would be very low in count number. This plot where you're very full should be very low in count number, and this plot should be a uniform distribution, or maybe not even a uniform distribution. Yeah, I guess maybe like a uniform distribution throughout the day. Right, that's what I would call a healthy station. And I had picked this station on purpose. This is a station that I know to be very underserviced. So that's kind of all I wanted to get to today. I was thinking that next time I would go and look at, start looking at other stations as well in the map. Because this whole time I've only been working with this one station. And it would be really useful to actually compare versus other stations. So I might be able to do a little bit of that today, but the reason I won't really get around to it is because it does take a little bit of time right now for me to load all this data. And actually, this is a good time to show what the data that I'm loading looks like. And I should have it open. I do, right here. What is the y-axis? All right, yeah, let's go back to these plots. If there's questions about these plots, the y-axis here is the number of times in my data set that I have found the station to be within a certain capacity range and hour of day, right? So, for example, this single bar right here tells me that there were between, let's say that's like about 260, 270 instances in my data set where the data was collected at midnight, so 0 o'clock at midnight, and the station had capacity between 0 and 33%, if that makes sense. How's it stratified by capacity, but also showing capacity on the y? Yeah. So that is a good question. The y-axis is actually not capacity, and maybe since I got a little bit of time, I can actually show what this data set that I'm looking at is. So this is the data set itself, right? So you'll see a bunch of JSON files that are time-stamped, right? And if I open up one of these JSON files, what it is it's this collection of every single station in the bike sharing network, right? And each station entry gives a snapshot of the status of that station at that point in time, right? So this data is all publicly available, but it's available in this JSON format. So, for example, this station, right? Station ID number 3. At this very point in time, has 15 available bikes, 0 available free docks. So that's in total there are 0 plus 15 total number of bikes that could be there at that dock. And then this is sorry, I was reading one of the comments. Yeah, and then this, this is repeated, right? I have this data for a bunch of different times, starting from last November, the end of last November, up to about last week, right? This isn't a probability distribution because the x-axis is time. It is a probability distribution, right? Because, yeah, so the x-axis in this plot is hour of the day, right? Of any day across, the sampling of months of data. And then the y-axis is the number of times that I've found the station, the specific station that I'm looking at, which is station 57 or something, to be within a certain capacity range, right, during that hour. Right, so for example, this data right here was collected at 10 a.m. And then if I go down to station 57, I guess it wasn't 57, because this station is out of service. Let's just say it was 56. You could see, so this station had 10 docks available, right, and 8 bikes available, and so a total possible number of bikes of 18. So So the station was about 50% full, a little bit less than 50% full at the time, at 10 a.m. on that day. So this means that this counts as one count on this plot right in the middle, because it was at about 50% at 10 a.m. So this bar goes up by one value. It's stratified by the capacity itself. Yeah, so this is kind of a bit of a more complex looking plot, because it's really like a two-dimensional probability distribution, right? There's two axes, independent axes, which are hour of day, and then range of capacity. Those are the two independent axes. And then the dependent axis is number of times that I've found the station to be, at that capacity at that hour of day. Yeah, I hope that makes sense. And if there's some better way to visualize this, that would also be really, really useful, I think, as well. This is just kind of my first pass at how I think I would want to visualize this. But kind of in my head, I'm thinking, it would be cool to take this data somehow and project it onto a map like this that shows all the stations, right? And use this data as some way to, oh, there goes my timer. Time's up. I'll have to wrap up the stream, but yeah, just to finish my thought, I kind of want a map. I basically want a map of like station health, right, across the system. And that kind of map would be useful for an operator to decide, say, oh, like this area here is very empty. I should put more stations there, or I should try to refill those stations by bringing bikes from other stations to those empty stations, which is what they already do. They just don't do it that well. I mean, you can see how empty these stations are, right? So the operators aren't really doing a good job of keeping up with the demand. Okay, they call it a joint distribution. Gotcha. Yeah. I am not super familiar with stats and probability theory, other than like a couple classes that I've taken. So this is definitely a learning experience for me, which is sort of part of what I wanted. And also a heat map might be yes, that is exactly what I mean. A heat map that's sort of like distributes like a cloud of by region, basically, of where stations need more bikes, where stations need less bikes, etc. So that's kind of the grand vision. Yeah, I might have described that a bit better in the first video. So if you guys have the time to check out that first video, that might clarify things a bit more. But yeah, that's it for today. I'm going to wrap up the stream. But thank you all so much for joining. Really, really, really appreciate you taking the time and interacting and providing me with feedback. And also I got to learn a bit, got some ideas for what I could do next time. So thank you all very much, and have a good one. Peace.